Assalamu alaikum everyone, welcome to another video about introduction to Python. This is Puya, and in this tutorial I'm going to talk about collections module, which is a built-in module in Python, so you don't need to install it, and you simply can access to its function by just, or classes, by just importing it. And from this this module or library, whatever you like to call it, we are going to talk about 4 items: defaultdict, counter, namedtuple, and ChainMap. So without further ado, let's begin. So the first functionality we want to talk about is ChainMap. ChainMap groups multiple dictionaries or other mappings, but in this example, we're just going to talk about dictionaries together to create a single and updatable view of those dictionaries. So let's see an example. To import ChainMap, simply from collections, import ChainMap, and it is imported. Consider you got just some dictionaries. In this case, we've got 3 dictionaries, as you can see here, and we want to chain these dictionaries together. We want to have have just single view of this dictionary. For doing so, we can use ChainMap, and we'll see what the ChainMap does. And as you can see, exactly as its name suggests, it chains some mappings. And as you know, dictionary is a mapping that maps the keys to values. So it chains these 3 dictionaries together in just one view, so we can see all this dictionary in one view, and we can access to all its items like a usual dictionary we've got. So we don't need to iterate over each of these dictionaries one by one. Just simply by iterating on the chained map items on the chained dictionaries, we can have access to each of the items from each of these dictionaries, like this one. So as you can see, E is equal to 5, and E is equal to 5, F is equal to 6, and so on. The rest of the values are here as well. We can access to the maps by just fetching the value from that maps, and here we've got a list of dictionaries that we appended at the beginning. We created our chain map over them at the beginning, and also it's updatable, which means we can add new dictionaries. And as you can see here, we've got a result, and or result, which was our chain map from this line. We can add. Okay, let me restart my kernel. So yeah, yes, okay, okay. So here we got dict4, and I want to add dict4 to the result at chain maps, and create a new result, create a new chain map, which is called res, or just simplified result. And as you can see, the new chain map is here at the beginning. This is the item 4, and also this is not it. You can append to your maps, because as we saw here, maps is just a simple list of dictionaries. So we can append another dictionary to our map, to our maps, by just a usual append method from lists, and we can add a new dictionary like this one. And as you can see, our dictionary is at the end of the file. It goes to the end of the list like this one. And again, we can iterate over the maps like this one, so you still have access to all the dictionaries. More importantly, you can access values one by one. It seems like a usual dictionary. Okay, it's not just like a simple list of dictionary. Consider we want to access to B, but we got 2 B's, so it returns the first one, as you can see here. we've got two B's, as you can see, the B at the first dictionary and the B at the second dictionary. So it returns the first B here, and you can reverse the list of dictionaries like this one, and again append it to res.maps, and again you can access to the B at the end of the file, as you can see, because it is it comes before to B, which its value is 0. So by using this, you can have access to different items, and you can keep your items that their keys are the same in just in one single dictionary. But this is not the case when you want to use the usual dictionaries. Like this one, we've got 4 dictionaries, and the B at dictionary 4 and the B, we've got 2 items that their keys are the same. And if we want to use the usual dictionary to combine all those dictionaries together, it's not possible, because as you can see, we are gonna at the end we're gonna have one key, because that's how dictionaries work. So if we want to have one single view from your dictionaries in just one item, in just one object, so you can access to different keys and different values, and you can iterate over these values, and you can access, and you also can have access to all the dictionaries through maps. ChainMap is the best option. Is the best option you got, and also it works like a usual dictionary. You can add new values to it, like this one. I added like Puya, and it's gonna add this new key value item to the last dictionary that has been appended. And also you can update a key. For example, here m is equal to 13, and you can update m value to 10. So here m was 13, and I updated to 10 by this line of code, and as you can see, the value of m is equal to 10. And also you can pop values, and as I said before, this just changes the values from the last dictionary. It's not it doesn't changes the items or values from the previous dictionaries. For example, here f is equal to 6. At the last dictionary we don't have f, so I'm gonna like res f. You can't update f because it is not in the last dictionary. It is not an item in the last dictionary. For example, f is equal to 6. I'm gonna say, for example, f is let's set f to 16. It's gonna create another f in the last dictionary. So you can also pop from the last dictionary. So it has all the functionality that the usual dictionary has, and also you can access to different dictionaries. You can have a view. You can iterate over all the dictionaries. So if you've got a list of dictionaries and you have to iterate on the values of each dictionary, or you want to have a single view which can be updated with new items, and you can, for example, assign a new value, update the previous values. ChainMap is one of the options you should consider. So nametuple. Nametuple is a subclass of tuple. Because we haven't talked about subclass, so don't consider it, which we're gonna talk about in future videos, but it's not gonna affect your understanding from this section. So consider a tuple, which we talked about. We worked with tuples. To access the items in a tuple, we had to use indexes. For example, if we wanted to get the item in the second item from a tuple, you should have used index 1. But nametuple says if working with indices is not your best skill, your best capability, you can kind of convert your tuple or a sequence to a class-like object, so you can access to its items using filled names. using yeah, exactly, using field name. An example will clarify this options, will illustrate this issue. So consider we want to create a tuple of 3 items, okay, like this one. Let me create a tuple of this 3 item here, and I'm gonna call it a student, and this is a tuple. So if we want to access to item in index, you want to get the name, the first name, you should go on with a student like an item at index 0, okay? Or you want to get the age, you should go on and use index 1. But the problem is you have to memorize which index relates to which identity or to which entity in your mind. So the name tuple says, you know what, let's get rid of that and let's have a named fields. So how to do that? For creating this functionality, you simply import name tuple from collection. You call the name tuple. You provided a name. It doesn't really matter what you provided, but it's conventional to. It's better to just name. Use the same name for variable and for your name tuple. So when someone sees this, they're gonna understand. They're gonna. It's gonna be easier for them to read your code and understand your code. I don't know whether it works or not. No, it seems it doesn't work. Type names and fill in must be valid identifiers. Yeah, so in this case, they should be the same. I wasn't aware of that. So student name and a student, they both should be the same. So you don't have any options. It's your variable name or your tuple class name, and and the name that you provide for your name tuple should be the same. But it doesn't matter. You can change this one or you can change this one. It's not gonna change. It's not gonna change the functionality. After the name of your name tuple, you should go on with a list of features, with a list of column names, with a list of fields that your tuple is going to work with. So the first item at index 0, you want to call it name because it's name. Okay, Zahra is a name, my friend who provided this codes. And for example, her age is 21 and date of birth is this one. So this is a list of fields. You can have a like larger list of fields or a smaller one as well. It depends on you. But in this example, we're going to use 3 fields. And after creating this student, you're gonna call this one and you're gonna pass the values. Easy as that. Okay, it's simply like calling a function. You're calling it and you're passing the values like Zahra 21 and this date of birth, which she wanted to pass it as a string. Okay, so here we got a student, and as you can see, and it says the student, the field name is equal to Zahra, age is equal to 21, and date of birth is equal to 1380. And you, like a usual tuple, you can access the item using the index. It's totally okay. The indices are there. So for accessing the items, you can still use the indexes. But what is the case if you want to access the items using the indexes? You wouldn't like implement them tuple. Here you can access the values using the field names, like this one. For example, I want to access like age, or I want to access the name of this student, or I want to access the date of birth, DOB. And you can use the intelligence as well. As you can see, I don't type anything. I'm gonna click on tab and this one blinks and it fills the DOB here. So it's gonna help you in the IDE that you're using. It's gonna help you and suggest the possible completion for you, like this one. So you can access the items using indexes, you can access the values using indexes, or you can access the values using the fill in. That makes it super cool. And also it provide some other functionalities, like for example replace. As we know, we cannot change the values of dictionaries. Okay, for example, you cannot change the value of like that name. You cannot change its value. You cannot like set it to booyah like this one. Okay, it says can't set attribute. It doesn't matter in name tuple and in simple tuples, usual tuples, you cannot change attributes. But name tuple provides a method for this case, and it says if you want to change a value, I can do it for you using replace. If you want to assign a value to one of the named values, I can do it, but I'm gonna create a new tuple. It's better than nothing. It's better than getting an error. So as you can see here, it creates a second object, which I assigned it to S2, like this one, and still S1 is equal to the previous one. You could have override S1 as well, so you would have only one object with three values, and this one would be overridden. That's possible also, but you have to remember this this point that replace does not really replaces anything. Okay, it just creates a new object, and you can override your new object on your old one, like you can override S2 on S1, so you would only have one object, but in reality it doesn't replaces the value because it's not possible. The set attribute or assigning attribute to a value to a field to a named field in name tuple is not possible. There are several ways you can create your name tuple. You can create it uh, by unpacking a dictionary. We talked about unpacking in this video. We talked about unpacking. Let me show you. Pause very quickly. Function advanced object. We talked about unpacking, how we can unpack dictionaries and other stuff. I think it was in this video, mandatory positional and key. Yeah, key args and key WRs. Inside the args and key WRs, we talked about unpacking. You can see the video from that link if you don't, if you haven't watched it before. So by using unpacking, you can create your object from your name tuple like this one. Again, this is how it goes. And also you can use lists. We got two options, you're going with make or just using unpacking. Let me call it, it's not recommended. It's better, this unpacking is recommended. And like this one, you can create your object. And it says, for example, Puya, blah, blah, blah. And again, using unpacking, it creates another object. So to conclude about a name tuple, if you think working with indices can cause you some trouble, and you may make mistakes while you're accessing your to name tuples, or not about you have a tuple and you want to kind of make it easier for your user. Okay, maybe you have a tuple and your users are gonna use it. In that case, name tuple will make it much easier for your user to relate to your to understand your tuple, because obviously when they see that it has a name, it has an age, and it has a DOB, they easily understand which index relates to which entity. The third object I want to talk about is counter. Counter simply is going to create a dictionary object which counts sequences of hashable objects. Why hashable object? We've talked about hashable and unhashable object. Why hashable objects are important? Because it creates a dictionary and it counts the items inside of a sequence. If you have an unhashable item in your sequence, like a list or dictionary in your sequence, in that case, the counter cannot cannot set it as a key, because dictionaries does not accept unhashable object as their keys. So that's why if you want to count a sequence of hashable objects, you can go on and use counter. They work pretty well. Let's see an example. If you consider you got a sequence of a string variable, which is a sequence of characters, huh? So this is my like GitHub ID, and I want to count the characters. I want to see how many O's are in here, how many M's are in here, and so on. If you wanted to go on with usual knowledge of Python that we had so far, we would have done something like this. I think this is the best we can do, huh? We got a counter, which is equal to dictionary, and for each character inside our sequence, we're gonna assign to our counter the letter, and we're gonna get the letter from the counter. Definitely at the first time, the counter is empty. For example, for P, the counter is empty. So want to get P, but obviously there's nothing assigned for P, so it returns. We say if the letter does not exist in counter, just return 0. It means its occurrence is 0. So and then plus it with 1, simple as that. This is how we count it. So you can see P is equal to 1, which means on P occurred just one time. For example, Y occurred again one time, but O occurred 3 times, M occurred 3 times. So this is how we would usually counter items inside of a sequence. But collection provides a simpler object, which is called counter. You just need to call this object with your sequence, and that's it. And it's gonna do the same for you with more options. You can call the elements. It's like getting the items one by one. You get the elements, like we got 1p, 3 O's, YA, 3 A's. We got 1 dash, the beginning, or a hyphen, and again 3 M's, and so on. You can use most common, which is the most common method used in counter. By calling most common 1, it's going to return you the most common object. In this case, O is the most common, but you have to remind this option that it gets the first most common. Okay, it doesn't return the all most commons objects. For example, with calling the 4 first most commons, you've got the 3 most common and the 4th most common, most repeated item in your sequence. And the good point is that you can simply update your counter or with another sequence, and it can apply it to your previous list of items that you had, like this one. And again, you can get the most common. It's not for characters, okay? You can, let me provide an example. You can go on and count the items inside of a list. Consider we got a list of integers, and we want to count the items like this one. This is exactly like the previous items that like this string that I showed you. We have only one inside our list, and we have 3 9s inside our list. As you can see, we've got 2 5s inside our list. Okay, let me provide another example. Your does not need to be a one kind. Okay, we can have like this one and this one, and as you can see, it says that we got 1 5 integer, we've got 1 5 string. So you can have as many items as you want, but it cannot be unhashable. For example, here we cannot pass it another list. As you know, lists are not hashable. Lists are not hashable. So as you can see, the counter says on hashable type list, you passed in inside your sequence, you got an item which is unhashable, so it does not work. Or sequences with unhashable objects. Sequences containing unhashable object. So again, if you want to count items inside of your sequence, counter is there to save you from coding manually, and also good point is that you can update your counter, and also you can get the most common and some other features. So the last object we want to talk about from collection module is default date, and maybe this is the most used property from collections, and we'll see how it works, and you're gonna love it. It creates a dictionary, okay, but what it does simply, it supplies the missing values. If you try to get a value from it, it provides if you want to get a key from your dictionary, from your default dict, if the key does not exist in that dictionary, it is gonna create uh, a, a default value for that key, and it's gonna prevent key error. And we'll see how it's gonna help us in some examples provided here. Consider we've got a dict. In usual case, in usual scenario, which we use dict like this one, we've got two keys like A and B. When we want to fetch the values for key A, key B, we'll have the values is 1 or 2. But what if we want to get the value for C? It returns key error. It raises key error because C is not defined. And consider, for example, you're counting items inside of a list. So in that case, it's common sense when it says A is equal to 1 and B is equal to 2, it means that A occurred 1 time, B occurred 2 times, and when you want to get C, if C is not there, is not defined, it means that C occurred 0, okay? It never occurred. So you really don't expect to get a key error, you expect to get 0, because it's a common sense, it never occurred. So let's just return 0 while you're raising a key error. In this case, which this is a common sense for you, when the value is not defined, it means that you should have a default when the key is not defined, you're looking for a default value. In that cases, default key is the best option you got. Let's get back to our count example. For importing it, it's just simply from collections import default dict, and you're going to create a default dict. Because we are counting the items, we are going to go on with we're going to pass int to our default dict, which means that whenever a key is not defined, just simply uh, um, uh, fill in the missing values with default int. And yeah, we know that the default value of int is just simply calling the int, which is 0. So the default value of int is 0. Let me call it default value, and let me print the default value. So as you can see, we're for C, which is not defined, we're gonna get 0 because it fill in the values. And let me show you the output of dict. After calling the C, it's gonna say A is equal to 1, B is equal to 2, but C is equal to 0. So this is how default dict works. It's gonna fill in the missing values for you. Here we can have a default dict of lists. So we know that the default value, let me show you, the default value of list is an empty list. So when you are working mm, on a list of items, and you want to just create a dictionary of lists, and sometimes you may encounter a list which is empty. You may encounter a key which has an empty list. In that case, if you want to prevent key error, you simply should create a default dict which list is passed as its default factory. So whenever you try to access a key which is not defined, the default dict is gonna call list, which creates an empty list like this one. As you can see that the dict is empty, and let me call the dict, and you see that it creates a default dict which the values are list, and C is equal to an empty list. You can do it for any kind of default values. Whatever you pass in here, default functions, whatever you pass it here should be able to be called and provide an object. Like this, you can go on with list, you can go on with set. Set creates a default set here, which is empty again, and you also can, for example, C dot add like P, okay? As you can see, we added P toward set. We can add so many items to our set, like we can add D, and we also can go on and add to our D. As you can see, D is not defined. I'm gonna add like Puya to D, and I'm gonna add again my name to D. All of these options are possible, and as you can see, without any errors, it just creates an empty set of list for me and appends and add my items to that set. Here there is an example for list again, a range of items. I appended to list, and as you can see, 0 is equal to a list of 1, 1 is equal to a list of 1, 2 is equal to a list of 2. And for counting, as we showed here, let me show you this example. Yeah, this was the example of counting, huh? Using default dict, we can count, not that one. This was the example of counting. Okay, let's consider I want to count the items in sequence, and I'm gonna just say letter or character in sequence, and obviously let me comment this. Obviously, using counter is the best case for counting a sequence of items, but this way of counting is much better than just getting the item if it doesn't exist, just providing a list, a default value. But this is exactly the same. This is what default dict does. If you don't have an item, it provides an item for you. And again, it does the same functionality we implemented in the previous section. It counts the items, but with simple difference. We don't need to use this section for manually implementing the default values for missing keys. And this is an example for dictionary. It creates a simple an empty dictionary if the key is not available, and as you can see, you can consider it as a usual dict, because it is as a usual dict, and you can, for example, define a new value for it, like this one. The name is not defined, but it creates an empty dictionary for it, and I'm gonna assign a new value to it, which is called Puya and Mohammadi. For example, I'm gonna add my friend's name as well here, so it perfectly works. We could call it friends as well. As you can see, Puya, Mohammadi, Zahra is in the names, and Zahra is in the friends as well. So when you're working in your project and you don't want to use this kind of tricks for a dictionary, and you want to simply go on with your dictionary without being worried for your missing values, and you're kind of sure about the values, you're sure that the values have the same type, like all of them are integers, all of them are lists, all of them are dictionaries. In that case, defaultdict is the best options you got. It is not used for counting, okay? It can be used for lists and a lot of options that we'll see in the next section that we are going to implement an example, and we'll see how we can use it in a real example. So let's implement an exercise. The exercise says, in a set of English words, list and count the number of words with the same anagrams. So what are we going to do? Well, this is a definition of anagram. What is an anagram? It says simply by replacing the characters inside of a word, you can create another word. Consider brush and shrub. All of both of them are consisted of S, H, R, U, and B, but their places are the places of characters are changed, but they are consisted of the same character, same set of characters. So this is two of our anagrams. So what do we want to do in this exercise? We want to list the words that have the same anagrams. For example, brush and shrub has the same anagram. So we want to list them in one list. We want to say, for example, these two are the same anagram. And also other words from our English word set, we want to get them as well. Just put them in different lists. And we want to count the number, for example, a shrub, how many anagrams shrub has. So we want to count the number of anagrams as well. So a very important note, before continuing to watch the video, please try to implement this example by yourself. It's going to help you to enhance your coding skills. It's going to help you to be able to provide different solution to different problems, because I'm going to provide a solution, yours might be different. And if you try yours and after that watching the video, you're going to have two sets of skills, two sets of solutions for one problem. So I encourage you guys to just pause the video. This is a YouTube video, so you can access it at any time, and just watch it after you've tried. So let's go on to implement the code. We got you may have different ways to access English words, but I want to use a very simple GitHub repository which works with which is called English Words. And to install it, you can simply go on with pipe and install English Words, or you can install it using the codes on the GitHub. This is recommended, of course. After installing it, you can access the English words like this one. Here, consider we got an English words set, and it consists of 25,487 words. So we've got a massive list of set of words here. Okay. So as you can see, like we've got some uppercase words, and we've got lowercase words, and so on. So we have to make sure to make some pre-processing in this code, because we don't want to, for example, Bruce with a small b should not make any difference in our anagram set. So we're gonna say English words. Other than this pre-processing, I don't see anything we may want to apply. I'm just gonna create a I can go on with comprehension, even with a set comprehension, it's okay. I want to say for word in English words, just want to make it lower. Let me make sure how it is written. str that lower, yeah, simply lower. And that's it. We print it again. Let's see. Yeah. Let's see. Do we have Bruce here or not? Okay, I don't see any uppercase, so it works. Okay. And you can check it. We saw Bruce, and we can say whether Bruce in English words or not. It says false, so we're pretty sure that it's okay. I don't see any other pre-processing we should do on our data. I think just converting it to lowercase would be okay. And that's it. If you noticed any other pre-processing, just comment it for me as well. So we need a way to realize that, for example, brush and shrub are, sorry about that, brush and shrub are anagrams. So what options do we have? Uh, I want to say, because we know that the setup characters should be the same. In that case, I'm going to implement a function. I'm going to call it get signature. I don't know whether I'm spelling it correct or not. It's going to get a word and it's going to return the sorted characters of that word. And we'll see what it does. For this case, I'm going to call brush. Oh, what's brush, huh? Brush and shrub, yeah. The brush is converted to a list. And I'm going to go on with, I want to check the shrub as well. And as you can see, both of these values are the same. So let me check whether are equal or not. So yeah, it says these two words are equal because the sorted characters of these two words are the same. Yeah, but the signature of converting it to a list may not be easy to use. So I'm gonna just join the characters from this list. How I'm gonna join it? In between, you can put on a space like this one. It provides an empty space. You can put like a dash. It's gonna put a dash between your strings, or simply you can say, you know what, join the characters of this list of strings. Okay, you cannot join a list of integers. It's gonna raise an error. So if you want to join a sequence of items, the items should be a string. So here, for make it easier, I want to say just join them without putting anything in between. Just simply join them. It's easier, you know. Definitely comparing these two values are easier for me. So I provided a signature which says for understanding that two items are anagrams or not, I'm gonna just use this signature. And also I can create another function called is anagram or not. Anagram or not. I don't know whether I'm gonna use it or not, but it could be it could be a great exercise to just try to implement your code by creating different functions. To check whether two items are anagram or not, I can go on and say, for example, word one, get the signature of word one, and compare it with word two, the signature of word two. If the signatures were equal, you're gonna get a true if the signatures were not equal, you're gonna get false. So I can go on with type hinting as well, so to make it much better. So for example, let me use this anagram, whether brush is equal to shrub or not. Are these two characters two words anagram or not? And as you can see, they are. So let's get back to example. What do we want to do? We want to list the anagrams. We've got a massive set of words here. So what I do for listing, I know that each value, each set of anagram should have a list. So which properties, which functionalities we talked about could help me more in this example, help me better in this example. The default dict is the case. So what I'm gonna do, I'm gonna call the default dict. Let me import it from collections, import default dict. And inside default dict, what do? I say, because I want to list them, so let's have a list, an empty list. And I'm gonna call it anagram list, whatever, it's up to you. So what do? I'm gonna start a for. I'm gonna I'm gonna create a for loop over the English words, like this one. So I'm gonna say get each word from for each word from this English words. What do I want to do? First, I want to get the anagram from it. Okay. So for anagram, we use get anagram. I'm gonna pass in the word, so it's gonna give me an anagram. Make sure whether it works. Let's check the first anagram and said AKU. I don't know whether it's a word in English or not. So we've got the anagrams, okay? And what do I want to do? I just want to call my anagram list and let's say, do you know what? This is my anagram and please append to the list that is responsible for listing the words of this anagram. Please append the word. So what do? Simply, I have a dictionary which consists of keys and its keys are the anagrams and its values are the list of the exact words. And that's it. It's in the example. And you can see this is anagram list. And for example, AKU, AUK, we got one word for it. And for example, let me get brush, okay? Let me call these, let me call get signature shrub or brush, doesn't matter, both of them are the same. So as you can see in our list of dictionary, we got just two words that are anagram to each other, and both of them are shrub and brush. We don't have any other character, we don't have any other options that could be would be the same of this words in anagram. Let me see whether do we have, yeah, like this one, Ellen, Neil, Lane, Len, Lena, this 5 words, 5 of them have the same list of, have the same anagram. So as you can see, it's really hard to check all the anagrams. You can, for example, sort the outputs. It's possible. You can get the outputs and sort them. And you can check them as you want based on the anagrams. Whether we are gonna find a better one, again, this one like Angel, Lange, and Angle, like Glean, Gallon. These 5 of them again, they are like each other. And you can check other anagrams as well. Now, let's get the second part. And the second part was about counting the items inside of the list. So for counting, okay, before we leave, let me see, is there anything that its anagram is equal to Puya? No, my name is not. Define in English. Okay, let me remove this one. So the counting part. For counting part, I can use comprehension. Yeah, we got anagram list. I can go on with anagram count. And I'm gonna say, okay, you know what? Let's call dictionary key value in anagram list dot items. We talked about comprehensions here. Yeah, if you check the video, the 19th video, we talked about comprehension, single if, and if a statement. You want to know how to implement list comprehension, dictionary comprehension. So for counting, I want to call the key and values, which is anagram and anagram lists, anagram list. I want to call the number of anagrams. So I'm going to just go on and say len of anagram list. And simple as that. And the key could be the same. Let's keep the key the same, which is the anagram. So here we have anagram count and the count of it. And as you can see, we've got a lot of options here, like 2 and so on. Let me get the max of it, the max of anagram count. Or for getting the max of it, we can use counter as well for getting the anagram anagram count. We can use the counter as well, so we can have access to our max as well. So here I'm gonna create anagram list 2, which is a simple list. And inside of the word, I'm going to get the anagram and I'm going to append it. So let's use list comprehension, huh? This one from English words, get each word and just get the anagram of it. Okay. So as you can see, look at the anagrams. Okay. And because it's list, so we can have repeated anagram. And over this anagram, I'm going to implement counter. I'm going to apply counter. Let me import counter from collections, import counter. So, and that's it. I'm going to call it anagram counter, like this one. This is our anagram counter, and I want to get most common, like get the first, then most common. Okay, we got just the most common anagrams are these 5 anagrams, like this one. Let me get from our anagram. What do we call this one? What did we call it? We call it anagram list. Yeah, we call it anagram list. We should have called it anagram dict because it was a dictionary, not a list. So we can get this one to see which are the anagram, what are the words for this. As you can see, like live, while, levy, evil, veil. These 5 words have the same. Each of them has the same anagram. So we talked about, we tried to use counter, default dict and default dict for counting and for listing. So each time you want to count something, you can use counter or default dict. But whenever you want to create a dictionary of lists, a dictionary of like strings and so on, default dict is the best option you've got. And I think that's enough for this example and for this tutorial. Like always, please subscribe to the channel, like the video, and click on the bell ring so you would be notified of the future videos. And also, you can access to all the videos that we talked about so far from my YouTube account and from my GitHub repository. Please consider introduce the channel and the GitHub repository to your friends. And till the next video, have a great time.